Good morning, everyone. Well, good afternoon, everyone. Thank you very much for dialing in and joining us for our live stream today. This has been put together by our Marine Fuels and Emissions Special Interest Group. So with IMO 2020 very fast approaching now, obviously it's been a very important topic to this special interest group, and it's been something that they've been obviously working on quite a lot. So we've got two members from our committee here today to talk to you about tank cleaning and preparation ahead of IMO 2020. I'll have both speakers give a presentation, and then we'll bring the speakers together afterwards to answer questions. So if you want to get involved in the discussion, please send in any questions on Slido. So just head to slido.com and use the code 7886, and then we'll be able to ask questions on your behalf here in the room. So with that, I guess I will hand over to our first speaker, Maurice.
Thanks. Thank you, Katrina. My name is Maurice. I'm Global Business Development Manager at Intertek Shipcare, and I'm going to look at the quality considerations for fuel, not only for tank cleaning and preparation, but general characteristics that the ship owner and ship manager should look out for, the fuel purchaser should. So, tank cleaning, we're going to start with this. You can see that there are four real routes to tank cleaning. The first one's the manual cleaning. Should it coincide with the dry docking, this will be a very good opportunity. You can see it's time consuming, of course it's expensive, and it's dangerous because people are going to have to get in and clean these tanks manually. Brushes, shovels, rags, in certain cases. Marine gas oil, flush through the marine gas oil needs to be carefully monitored, because marine gas oil is such an aggressive form of stripping these tanks that it really would result in blocked filters, problems with centrifuges. Less aggressive would be a very low sulphur fuel oil flusher. I know some of our clients prefer this option, but quite a number of our clients have taken this option, just to flush through with very low sulphur fuel oil. It's not as intensive as an MGO flush, and I think it's fair to say it's given good results. Additives, well, following me, we're going to be, my colleague Mike Banning from Innospec is going to discuss additives in great detail. So, as you can see there, it is a gradual cleaning process, and we've seen it from the data we saw with 0.10% sulphur fuels were introduced in 2015. It is another effective method. Key considerations: tank cleaning, the size, geometry, structure of the tank, the quality of the fuel loaded previously, the types of fuel loaded previously, and the current state of the tank, its cleanliness, its condition. Other considerations for new fuels: what else would you consider? Well, we've got the delivery of the fuel, storage, compatibility. We'll be talking about that. We'll be talking about that later, compatibility. Then the ship owner, ship manager should consider the treatment, particularly settling tank and purification, handling, critical importance, and fuel injection, fuel combustion profiles are causing some consternation at the moment, I think. Fuel availability. We were concerned that a year ago that these fuels might not be available, but we can see that from these headlines here taken from trade press that it is expected that there will be plenty of VLSFO available in the market prior to 2020. We know that a lot of our clients are already purchasing VLSFO with a view to going through with this stem into the new year, or as a method of tank cleaning. However, still a certain lack of familiarity with them for, I'd say, about 50% of our clients. There's no need to be concerned, because we've been here before. 2015, we had the 0.10% maximum sulphur limit applied to the emission control areas, and we introduced what were then called hybrid fuels, now called ultra-low sulphur fuel oils. And that worked very well. We saw an increase in off-spec fuels as these fuels were introduced, but as people got used to them, the producers got familiar with how to produce them, and how ship owners and ship managers and crew got familiar with how to handle them. They very quickly became an accepted and widely adopted method of complying. 0.50% sulphur fuels, well, what do they look like? We already know that we'll see some specifically manufactured fuels, particularly from the oil majors. There's some good availability on these, and we do expect that there'll be some blended fuels into the market. Blends of HFSO combined with unusual and some unregulated cut stocks, which we expect as we move towards 2020, these will give us some problems. There'll be a spike, an increase in problems, and that spike will be a spike, it'll very quickly go away. What should the fuel purchaser consider? We know from previous experience that legislative reform is associated with fluctuations in fuel quality, as viscosity and density are no longer the principal considerations. Sulphur control is the principal consideration. We've seen associated changes in the quality of the fuel. The 1.00% sulphur limit in ECHAs presented with issues with the type of fuels available for use. The 0.10% sulphur limit in emission control areas saw a significant improvement in the quality of fuels available for use, as some of the more problematic fuels were stripped out and no longer available in the market. Prior to January 2015, analysis of the data showed around 20% of fuels to have one or more parameter above the ISO limit, with around 12% being off specification. This is based on a single test result. Following January 2015, these figures dropped significantly, and only around 10% of fuels, down from 20%, showed one or more parameter above the ISO limit, with around 5%, down from 12%, being off-spec based on a single test result. You can see there the data for 2018. As we look through, you can see the average there is is that 9.7%?
Yeah.
9.7%, oh yes, 9.7% average. We can see ISO limits. Quarter 1, 9.6%, 10.4% for quarter 2, 9.2% for quarter 3, and they're up to 9.4% for quarter 4, with a yearly average of 9.7%. These are above ISO limits. You can see the general quality improvement as we get towards 2020. First quarter of 2019, 9.3%, 8.1% in quarter 2, and in quarter 3, 9.1%, with the average to date of 8.8%. So how was the industry prepared? Ship owners, ship managers, fuel purchasers. Fuels are purchased against the ISO 8217 standard, and this standard is reactive. So there has to be fuels in the market in order that those interested bodies can see what exactly is required, what the likely tests are. It should be stressed that VLSFOs can be tested against the current version of ISO 8217, specifically the 2017 revision, because that has parameters for cold flow properties. So it is essential that VLSFOs are purchased and tested against the 2017 revision of ISO 8217. There have been a number of documents produced by the industry, starting with the compliance with the 2020 Global Sulphur Cap by the International Chamber of Shipping. Then there was a joint industry guidance, fuel suppliers, testing agencies, classification societies. IBIA issued this document, joint industry guidance, and just in the last few weeks we've had the publicly available specification from ISO. No additional specifications for 0.50% fuels have been included. The publicly available specification provides additional guidelines to be used in conjunction with the 2017 revision of ISO 187. Different qualities of fuels require different methods of handling on board. The PAS considers additional needs, particularly in relation to the quality parameters tested. As I said before, it's essential that VLSFOs are tested against the 2017 revision of ISO 187. Is the 2017 revision widely used? Well, here are the figures we see in our laboratories. You see the 2005 revision of ISO 117, nearly 54% purchased against that revision of the specification, with nearly 46% purchased against the 2010-2012 revision. Doesn't leave much room for anything else, and we can see that 0.5% of fuels were sold in accordance with the 2017 revision of the ISO 187 specification standard. Stressed in the publicly available specification were a number of parameters: kinematic viscosity, cold flow properties including wax formation, stability, ignition characteristics, catalytic fines, particularly for any residual-based products, and also compatibility was considered. We've seen some product variation in very low sulphur fuel oils. We can see here a pour point from -12 to +30 with an average of 15. Again, cold flow properties are going to be very particularly worth consideration with very low sulphur fuel oils. Compatibility, we do anticipate that compatibility between very low sulphur fuel oils could cause problems, and management of the fuel on board is going to be essential. A lot of consideration should be given to this. A lot of preparation, a lot of input has been given by various industry bodies, including the fuel suppliers, who stress that compatibility is likely to be a major consideration. What do we expect? We'll see a significant number of blended very low sulphur fuel oils. We'll still see ultra low sulphur fuel oils being used due to the sulphur specification. We'll see continued use of heavy fuel oil in conjunction with abatement technology, scrubbers in other words. And MGO, for many, will be the immediate short-term compliance option of choice. So whether that continues to be so will depend on a number of parameters, including the availability of heavy fuel oil and very low sulphur fuel oils. How can we help? ISO and the 2020 transition. The analysis of fuels will provide an overview of the quality of the product. The vessel and the ship owner, ship manager, fuel purchaser will then manage the product on board. Cold flow properties will play a more significant role when specifying which fuel to add. As a result, heating will be a major consideration. Residual-based products might still contain sediment and catalytic fines. Again, compatibility is likely to be a principal consideration. The fuel suppliers are telling us this. Long-term storage could be an issue. I know that some people have talked about the use-by date for these very low sulphur fuel oils. Well, I have to say that seems to have not the issue. What's important? The ISO 82117 specification for marine fuels. Please bear in mind the cold flow properties in the 2017 revision of the ISO 82117 standard. The publicly available specification lists a number of parameters that should be considered. CMAC have been very helpful in recently issued guidelines. A wide variety of new fuels are entering the market, and a degree of caution naturally is essential. Knowledge of the fuel quality prior to use is vital. Also, the onboard handling of the fuel is critical, particularly segregation. Additional support and guidance are available in the publicly available specification and the joint industry guidance documents. Thank you.
Good afternoon, everyone. I'm Michael Planning from Innospec Fuel Specialties. I'll give you a brief overview of our company. I appreciate not a lot of people have heard of us. And then I'm going to talk about tank cleaning with the use of additives, as Maurice briefly touched on before, and just share some of our experiences. So Innospec is a publicly traded company. We're a US company, corporate headquarters in Inglewood, Colorado. We have regional offices throughout the world, UK being our main R&D hub where I'm based. We have manufacturing sites again all over the world: USA, UK, France, Spain, Italy, Germany. What we are is a fuel specialty company. So we only deal with fuel, and this slide is showing the areas we're involved in. We are wells and wheels involved in every area, from drilling, fracturing, stimulation, production, pipeline and storage, the refinery, terminal and storage, power industry, marine, heavy duty and fleet, passenger vehicles and aviation. So the mainstay of our business is automotive and aviation fuel. Innospec, in terms of the marine industry, we have a very, very large customer base, predominantly with refineries. So these companies like and respect our technical credibility. And in the marine industry, I represent Innospec on the ISO working group that sets the 8217 standard. I'm also involved in CMAC working group 7 for fuels. We like to have a lot of product verification proving that our products do what we claim, and we have quality assurance in place. So we are proud to say that we are part of the Lloyd's Registered Product Verification Scheme, and we've also had some of our products tested in Hamburg by Shell on their test engines, just to prove performance. So, like I said, I'm going to be talking about tank cleaning. What happens is that every tank will have an element of sludge in there. Using a gas oil or a solvent of some kind will cause that sludge to move from the tank into the handling system. This can be done slowly and in a controlled manner, or it can be done very quickly, and potentially you see the issues with block filters and purifiers in these pictures. So I just wanted to talk for a second about sludge. What is sludge? Sludge is predominantly made up of asphaltene molecules. So you can see this molecule on the picture there. This is a large hydrocarbon. Asphaltenes are fuel. They can be burned. It can be up to 20% of the traditional heavy fuel oil's content. These molecules are very large and are attracted to each other, and they can fall out and form sludge. And like I said, this is the primary constituent of sludge you'll see in your tanks. The other things are inorganic matter such as rust, dirt, sand, cat fines. So what I would like to do here is just to talk about how asphaltenes become sludge. So the large black objects in the middle are the asphaltene molecules, and you can see there are some resins with little tails around them. So resins are part of a fuel, and generally they tend to surround the asphaltene molecules and keep them in suspension. So what happens when you start to blend fuels or secondary refinery processes, these resins are lost, either stripped out of the fuel or start to react with other aromatics or other components within the fuel, and that leaves these larger asphaltene molecules open to agglomerate and be attracted to each other. And what happens is they get so large that they fall out and cause sludge, and that is the sludge that you see in your tanks. So I'd like to talk about what our additive does, how it works. So you can see that these, when these molecules go together, what we do is we use our dispersant technology, and that simulates the resins. So that keeps these asphaltene molecules fully protected, and they're also polar in nature, so they repel each other, meaning that it's dispersed and homogeneous within the fuel. So what that means is you have a stable fuel. So talking about tank cleaning, these molecules, the secondary effect I mentioned before, they're polar, so they start to move away from each other. But what you can do is the sludge that's already there, the additive is attracted to it and it can start to bring it up. So it starts effectively cleaning the asphaltene sludge from the tanks. So we, like Maurice mentioned earlier on, we had quite a lot of experience of this in the run up to 2015 in the 0.1% emission control areas. Again, we've started doing this and promoting this for tank cleaning in the run up to 2020. The main product we're using for this is Optimar BT25, which is a dispersant and a stabilizer, so it works in the way I briefly described before. And what we recommend is using this product over 3 bunkers. So what we would like to do, this is a dispersant, so it will move sludge. So if you do this quickly, it will block filters. So we recommend to do it in a slow and controlled manner. So the typical dosing rate is 1 litre per 20 tonnes of fuel. Over the 3 bunker cycles, we recommend to start at a lower dosage rate of 1 to 30 tonnes, build it up to 1 to 20 tonnes, and then the final bunker 1 to 10 tonnes. This means that the sludge is dispersed and it's homogeneous within the fuel, so you mitigate the risk of filter blocking. So, like I say, I just want to share a bit of our customer experiences. So the particular example I've picked today is from a large container shipping company who decided to use BT25 across their fleet to clean their storage tanks in service. Another advantage of using the additives is that you don't have to open the tanks and clean. You still have to inspect your tanks, which is good practice, but you don't have to go in and be subjected to scooping sludge out. The case study vessel is a 11,356 TEU container vessel that was built in 2011, so a reasonably new ship. So before they started using additive on this particular vessel, they inspected the tanks in March 2009, and then after 3 bunkers in August 2019, they went in again and inspected the tanks. I'll apologise in advance for the quality of some of these pictures. It's not always possible to get a good picture inside a tank. So most of the positive feedback on the condition of the tank and the difference between pre and post additive came from the chief engineer. So as you can see, where you go in there is sludge at the bottom of the tank. There's sludge on the heating coils. Again, forgive me, these aren't the clearest of pictures. However, after 3 months, the amount of sludge accumulation was significantly reduced, and this ship is now using a VLSFO in these tanks. So just to recap, it's a relatively inexpensive way to clean your tanks. It can be done in service, so there's less requirement for tank entry, and it's done over time gradually so that you don't get filter blocking. So that's it for me, and I'd like to thank you for your time.
So thank you both very much for coming in and giving your presentations. I guess I now just want to open things up to any questions. So feel free to chip in if there's anything that you wanted to add. I know that it's something we've already discussed before, or at least I know it's discussions that we've had with other groups. But I do want to want to make sure that the issue is raised, given that our human element group is working on this. But given that obviously cleaning tanks for low sulphur fuel oils will involve increased exposure in many cases to the major hazards relating to enclosed space entry, which in many cases is considered one of the biggest hazards on board. What advice would you give to ship owners and seafarers?
Well, I've been in many tanks during my time at sea, and it is not a pleasant experience in the slightest. In terms of advice, I would say you limit tank entry to the bare minimum. You have to make sure that you've got a proper control of work in place, and just follow safety guidelines to make sure that the tank is being properly ventilated and the atmosphere is tested not only at the entry to the tank but in the sort of smaller spaces where you are likely to have a lower oxygen content.
Yeah, this point was raised yesterday in an article in Tradewinds. I know the seafaring trade unions are particularly concerned about people entering these tanks. Of course, there's a number of hazards. Tanks aren't particularly built for people to go wandering around in them with bags and shovels and solvents. There's a lot of slips and falls could be there, but also gas in confined space. That's the real danger. Danger of asphyxiation to be in the confined space.
Is there anything missing from IMO advice and guidelines, or is there not so much? Sorry, not so much missing, but is there other aspects like that that haven't yet been fully considered that you're aware of?
I'm not particularly an expert on it. I used to work for one of the oil majors on their tankers, so we had quite a rigorous control of work, enclosed space entry procedures. So, admittedly, I only have experience on board. I'm not too sure what IMO guidance is.
I wouldn't have thought it was particularly in IMO's remit. Each individual ship owner will have a health and safety policy. As long as those policies are adequate and then followed adequately, things should be fine. It's a question of having the structure in place and then following it.
What do you think of trying to deal with disposal issues when cleaning out fuel tanks? Is there an environmental or a safety risk related to getting rid of the material that you remove?
Well, I know it's not cheap to get rid of sludge. There used to be places, say in China, that would accept it for free. That's not the case anymore. If you think about how large fuel tanks are, I mean, you can go from one for a couple hundred tonnes to several thousand tonnes, and that's just one tank. If you say you have 0.5% of that as sludge, it's an enormous volume of waste to get rid of. And let's not forget, it is heavy fuel oil, it is a hazardous product to handle. So I can see that there would be big issues with getting rid of that sludge.
Yes, there will be properly licensed companies in certain locations, but not in every location, and that might prove a problem.